Welcome, dear students. Dear students, you must have gone through the algebraic expressions in your previous classes. Today, we are going to learn about some special kind of algebraic expression, that is polynomial. This is polynomial part 1. In this session, we are going to discuss about polynomial in one variable, constant, variable, coefficient, degree of polynomial, zero of polynomial, naming a polynomial, and polynomial with more than one variable. So here let's see how to express the algebraic expression. What is algebraic expression is? Let's consider an example, that is the perimeter of a square. Here we have taken a square whose length of each side is 3 units. Then what is its perimeter? Its perimeter is 4 into 3 units. Now if we increase the length of the side, that is 4 units, then its perimeter will become 4 into 4 units. If the length of side will be 5 units, then its perimeter will be 4 into 5 units. If we don't know the length of the side of a square, let it be x units. Then what will be its perimeter? Its perimeter will be 4 into x units. Here comes the algebraic expression. When we consider 4x, it has two parts. One is 4, that is a constant, and another part is x, that is a variable. Why it is variable? If we look at these steps, in each square 4 is a constant, and what is changing? The length of the side is changing. That means here length of the side is our variable, which is taken here as x. Now usually in case of variable, you use the alphabets x, y, z, etc. And let's see some more algebraic expressions. 3x square, 7y to the power minus 3, 6y to the power root 2, 12u raised to the power 3 by 4, root 2, p raised to the power 9, and minus 3 root 2, z raised to the power 6, and 8 by 11, x raised to the power 8. These are all algebraic expressions. Out of these expressions, let's see 3x square, root 2 p to the power 9, minus 3 root 2 z to the power 6, and 8 by 11 x to the power 8. These four algebraic expressions are called monomials. Why they are monomials? What about the rest? What remains here? The remaining algebraic expressions are 7 y to the power minus 3, 6 y to the power root 2, and 12 u to the power 3 by 4. What is difference between these three? Why these four are called, the below four are called monomials and the rest are not? If we very minutely examine the exponents of the variables, we see that in encircled expressions, the exponents are negative and not integers, and so and so. But in case of the expressions written below, the algebraic, the exponents given here are all 0 non-negative integers. Now see, then what is monomial? If a, where a is not equal to 0, is a constant real number, x is a real variable, and n is a non-negative integer, or we say whole number, then algebraic expression a x to the power n in x is called a monomial of degree n, and here a is called the coefficient of the monomial. Then what is polynomial? Polynomial is nothing but an algebraic expression where we may have one or more terms and each term is a monomial. Then the algebraic expression is called a polynomial. Polynomial in x is usually denoted as p in parenthesis x. Any polynomial can be expressed in this form. Not only p, we can use any other alphabet also to represent a polynomial. Let's see some algebraic expressions where they are polynomials or not. See, in this case, we have in first one, px is equal to 2x square plus 3. That means this 2x square plus 3 is the polynomial, and this is represented by px. Similarly, in second one, the polynomial is minus 3y to the power 3 minus 3y plus 5. And what is the variable? Variable is y. So, the polynomial is denoted by qy. It may also be denoted by py. Similarly, other also are given. Now, let's see what are the number of terms and what are the terms and what are the highest exponent of the variable and how to find the degree of the polynomial. In first case, see, number of terms is 2. Then what are the terms? The terms are 2x square and 3. And what is the highest exponent of the variable? Here it is x square, so value is 2. So here we can say the degree of polynomial is 2. In second one, qy, the number of terms is 3. And what are the terms? Minus 3 y raised to the power 3 minus 3y and 5. And what is the highest exponent of the variable? It is 3. So, degree of polynomial is also 3. In next one, we have 4 terms. What are they? 5p raised to the power 3, 3p square, minus 5 and 2p. And what is the highest exponent of the variable p? Here p to the power 3, so 3 is the highest exponent. And so degree of this polynomial is 3. Now let's consider the next one, that is pu. 10 u raised to the power 3 minus 3 u raised to the power 12. So number of term is 2 and the terms are 10 u to the power 3 and minus 3 u to the power 12. So the highest exponent is here 12. So we can say that degree of polynomial is 12 here. And last one, see, it is minus 9t to the power 5 plus 2t square. This is a polynomial with variable t, so it is written pt. So you can see that number of terms is 2 and the terms are minus 9t to the power 5 and 2t square, and highest exponent of variable is 5 here. So degree of polynomial here is 5. In all these cases, we have one variable only. In first one, the only one variable is there, that is x. In second one, again one variable, that is y. In third one, the variable is only p, and in pu, the variable is u, and in pt, the variable is t. So these are called polynomial in one variable. Next, we see that px is equal to 2x plus 3. This is another polynomial. And what is the degree of this polynomial? The degree of this polynomial is 1, because power of x is not given, that means its power is 1. And so it is called a linear polynomial. Why it is called linear polynomial, it will be discussed later. Now see, if the degree of polynomial is 1, how many terms, maximum term can it have? It can have 2 terms. It can also have one term, say 3x. 3x is a linear polynomial. Okay. Next, we see the general form of linear polynomial in x is ax plus b, which is where a is not equal to 0. That means if the polynomial is linear polynomial, the coefficient of the x must not be 0. Then only it can be a linear polynomial. Next, consider another polynomial, that is 2x square minus 5x plus 1. This is again a polynomial with one variable, and its degree is 2. The polynomial with degree 2 is called quadratic polynomial, and its general form is x square plus bx plus c, where coefficient of x square must not be 0. Now see, if the degree of polynomial is 2, then what can be, how many terms it can have? It can have any number of terms between 1, 2 and 3. That means if we write only ax square, then it is a quadratic polynomial. Ax square plus bx, again it is a quadratic polynomial. X square plus c, it is a quadratic polynomial. But if we write bx plus c, it will become a binomial of degree 1. So the coefficient of x square must not be 0. Now, by studying these two, we can say how many terms a polynomial in x with degree 3 can have. These polynomials, the degree of polynomial is 3, then the polynomial is called cubical polynomial. In this case, the number of terms are between 1 to 4. As we can see that 4x cube plus x square, this is cubical. 4x cube plus x square plus x is cubical. Only 4x cube is a cubical polynomial, and 4x square plus 4x cube plus 3x square plus 2x plus 1. This is also a cubical polynomial. So we can have number of terms to be 1, 2, 3 or 4. Okay? Then its general form is ax cube plus bx square plus cx plus d, where, as it is discussed before, a must not be 0, as it is a cubical polynomial. Now here you see the number of terms in all these polynomials are finite. That means we have a finite number of terms in any polynomial. If that number of terms is n, that is, as we consider in cubical, we have number of terms, maximum number of terms in are 4. So if the degree of polynomial in x is n, then what is its general form and at most how many terms it can have? We can write this n degree polynomial as a0 plus a1x plus a2x square plus a3x cube, and in this way up to an minus x to the power n minus 1 plus an x to the power n, where a0, a1, a2, a3, in this way up to n minus 1 and an. Why we are writing like this? As in last case cubical cubical polynomial, it was given only 4 terms, so we used a, b, c, d. But here number of terms is not known, so how to write the coefficients? So a0, a1, a2, a3, in this way we have to write the coefficients, and these are constants. Okay, and as this is n degree polynomial, so an must not be 0 and n is non-negative integer. Here px is called a polynomial of degree n. Then this polynomial has terms a0, a1x, a2x square, a3x cube. In this way an minus 1 x to the power n minus 1, an x to the power n. What are these? These are, each of these algebraic expressions are monomial, and each of these monomial are called terms of the polynomial px. So you can see the, as it is written that n is non-negative integer, so each term is monomial and each monomial is a term of the polynomial px. If the coefficients a0, a1, a2, a3 and all these coefficients up to an all are 0, then what will happen to our polynomial px? And the polynomial px will become 0. If the polynomial becomes 0, then what we say about the polynomial, its degree of the polynomial? The degree of 0 polynomial is not defined. Then polynomial with more than one variable, these are x plus 2xy plus 3y. Here we have used two variables x and y. So to denote it, we can write say pxy and its degree. To find the degree of a polynomial with more than one variable, we have to add the exponents of each term, each variable of the term. In this way, if we see 2xy, here the sum of the exponents of x and y are 2. So here the degree of polynomial is 2. In second one, we have used two variables u and v, u plus uv plus 2u square v minus 4u vq. So here we can write that puv. So in this polynomial, if we find the degree of polynomial, you can see in the last term the sum of the exponents u and v is 4, which is maximum. So degree of this polynomial is 4. In third case, we have used three variables. So we can write p, x, y, z. Here also again see z to the power 3 is maximum, and the term next to it, that is minus 3 xyz, the sum of the exponents of the variables is again 3. So, degree of polynomial is 3 here. Now, we have discussed about different types of polynomials. Now, let us see some questions to recapitulate it. Let us look at this question. Here it is, which of the following algebraic expressions are not polynomials? To know about which are polynomials and which are not polynomials, as we have discussed, let us recall it that when the exponents of the algebraic expressions are non-negative integers, then they are polynomials. These algebraic expressions are polynomials. Now we have to examine these algebraic expressions to see which are in this form and which are not. If 3x square plus 5x, here the exponents of variable x are 2 and 1. Yes, 2 and 1 are non-negative integers. So, first one is a polynomial. In second case, root 3x cube minus 1 by x plus 5. Now, what is it? If we write minus root 3 x cube minus 1 by x plus 5, we can write this like this: root 3 x cube minus x to the power minus 1 plus 5. Here the exponent of x is 3. Here exponent of x is minus 1. Here it is a constant. As the exponent is a negative integer, so this cannot be a polynomial. Now see, third one, 5x plus root x. 5x plus root x can be written as 5x plus root x can be written as x to the power 1 by 2. Now, is 1 by 2 an integer? Definitely it is not. Then we can say 5x plus root x is not a polynomial. Now see, minus 7 x to the power 4. Here the exponent is 4. So, the it is non-negative integer. So, it is a polynomial. And 9 is a constant number and it is a polynomial of degree 0. So, only the encircled expressions are not polynomials. Let us see another question. Here it is, find the degree of the following polynomials. We have to find the degrees. The polynomials are 3x square plus 5x. Now, to find the degree of polynomial, we have to find the highest degree or highest power of the variable. Here in 1, 3x square, the exponent of x is 2, and in 5x it is 1. So, highest exponent is 2. So, the degree of the first one is 2. In second one, it is root 3x cube minus 27x plus 5. As you examine, the variable has highest exponent 3. So, it is degree, it is a polynomial of degree 3. In question number 3, 5x plus root 9x to the power 4 minus 1. In first term, the exponent of x is 1. In second term, exponent of x is 4. And in third one, the exponent of x is 0 as it is a constant. So, the highest exponent is 4. So, degree of this polynomial is 4. Now, In case of minus 7x to the power 4, this is a monomial and its degree is same as 4. Now in case of 105, it is a constant. We have learned that the constants are polynomial of degree 0. So 105 is a polynomial of degree 0. Today we discussed monomials in one variable, monomials in more than one variable, degree of monomial of one variable, 0 degree of monomial, that is constant. Constants are monomial of degree 0. Polynomials in one variable. Poly means more and nomials means terms. And general form of polynomials in one variable of degree n, that is a0, a1 x, a2 x square up to an x to the power n, where an is not 0 and 0 polynomial. In next class, we will study zeros or roots of polynomial in one variable. Dear students, today the lesson ends here. Thank you.